Hey, on this video, we're going to go over how to construct an acceleration time graph from a velocity time graph. So the steps that we're going to go through to do this, that I'll walk you through in the example, is first you're going to divide your velocity time graph into sections based on every time your line changes slope, right? Then you're going to, for each section, find the slope of the line. So your slope formula is rise over run. You probably know that by now, but just in case, there it is. So your slope is your rate of acceleration for the object for that time period. So once you do that, you're going to set up your acceleration graph, and you want your x-axis to match, and then you're going to draw a horizontal line on the acceleration time graph for the same time period using the slope as to where you're going to place the line. And I'll show you that in the example, and it'll make way more sense than this sentence does, probably right here. And then you'll repeat that for each section. So basically, to sum it up, you're calculating the slope, and then on the acceleration time graph, you're going to plot that slope on your graph for that time segment. Like, they're going to match, right? It's super easy. Hopefully you won't have a problem with it. So, all right, let's go on and do an example. Okay, so for this example, we are going to be making an acceleration time graph from this velocity time graph. So our first step is divide our graph up every time our line changes slope. So it does that at 3 seconds, does it at 6, because if this continued the same slope, we could not break it apart right here, but the slope does change ever so slightly here. So, and then it changes at 9, 12, and then ends at 15. So every 3 seconds, we have a different slope. So once you do that, you're going to find the slope for each section that you have. So for the first one, our rise goes from 2 up to 6, so its total rise is 4 meters per second. And then we're going to divide that by its run, which goes from 0 to 3, or 3 seconds. We don't want to leave it in a fraction form of 4 over 3. We want to simplify it into we want to put it in a decimal form, which ends up being about 1.3. It's 1.3 repeating, but we're just going to round to 1 decimal place. And then our units are going to be meters per second, or simplified into meters per second squared. So that's for the first section. Then the next one, from 3 to 6, we have a rise of -6 because it drops from 6 down to 0, and it does that in 3 seconds. So when we work that out, we get an answer of -2 meters per second squared. Now from 6 to 9 seconds, we're going from 0 down to -4, so our rise is -4 meters per second. Our run here is also 3 seconds, so we get an answer of -1.3 meters per second squared. Then the next one is easy. It's a horizontal line, so that is 0 meters per second squared. And then the last one, we have a rise of 2 meters per second, and then a run of 3 seconds. So that is going to equal we're going to round that to 0.67, all right? And that's meters per second squared. And if you rounded that to 0.7, that's fine as well. Okay, so next, if you don't have your graph paper already set up, you want to set that up. Here I've got my x-axis matching the velocity time graph, so every 3 seconds. And then I haven't labeled my y-axis. I'm just going to do that as we go, but you can already have that set up. So what you're going to do to make this is whatever your slope is going to be where your line goes on your acceleration time graph. So for the first 3 seconds, our slope was +1.3. So that is where I'm going to put my horizontal line at 1.3. Then for the next 3 seconds, my slope was -2. So I'm going to have down here at -2, and my y-axis isn't perfectly to scale because I'm doing this on a small iPad screen instead of on paper, but you get the idea. So -2, I'm going to put a line there, and I'm going to connect these with a dashed line. Okay. Then from 6 to 9 seconds, my slope was a -1.3. So that is where that horizontal line is going to go, and I'm going to connect these with dashed lines. Then from 9 to 12, it was at 0, so I'm going to put my line there, again, connect them. And then the last one was a +0.67, and then I'm going to have a line there at 0.67. So whatever the slope is where your line goes, all right? It's not like the position time graph where you're adding it on. You're just plotting it right there. It's always a horizontal line. Connect them with some dash marks, and that's it. So these are super easy to make compared to making a position graph. So hopefully you won't have any problems with it, but if you do, just let me know. I'll be happy to help you.